Hi, this video is to help you understand how to make quality scientific observations for our science class. The first thing to do is we want to try to incorporate as many of the five senses as possible in our observations. However, not all of their senses are safe to use in the lab. Sight is often one that we will use. However, we need to make sure that we wear our goggles when necessary. We also need to make sure that if there are certain activities where we are told to protect our vision using indirect viewing opportunities, we need to do that. So for example, if a person's burning magnesium ribbon, you don't want to look at that directly because it can damage your eyes. Smelling things in the lab is accomplished using the wafting technique that we talked about in the lab safety unit. When you waft a chemical smell, you want to make sure that you don't inhale too deeply, and you also want to make sure that you only smell things in the lab that you are told to do so. Don't smell just any chemical by wafting because some of them can still hurt you. Hearing things, you always want to listen. Are there noises being made while the activity is going on? If so, what are they? Touching things, remember, be careful. Hot glassware looks like cold glassware. And some chemicals, even though they look innocent and look like water, can actually destroy your body very quickly. So only touch things when told to do so. Tasting things, we do not taste things in our lab, ever. When you make your observations, you want to make sure that you record them and you're as detailed as possible in your data recording. That means you include the quantitative and qualitative data both. The difference between the two is going to be described now. So qualitative versus quantitative observations. So qualitative observations are using the five senses if possible. If not, you use the ones that you need to use to be safe. Quantitative observations are using measurements in numbers, such as how many grams is the object, how fast did it fall, so using timing. So you want to make sure whenever you're using your observation skills, you always put a label with it so people understand what it is that you are doing. Any questions? If so, please ask your teacher. The second thing we're going to talk about in this video is the components that are required for doing a fair test or scientific experiment. So the first thing we have to understand is what variables are. So variables are the factors in a fair test or scientific experiment that may be subject to change. There are different types of variables based on whether you are changing the item or whether the item or the response is being changed based on what you do. The independent variable, or IV, is the variable that you change or manipulate. So for example, are you making the object colder, or are you making the object hotter? That would be a variable that you could change to see how the chemical reaction takes place. Are you changing the height from which you drop the object? Are you dropping the object, or are you throwing the object down? Those would be examples of independent variables. The dependent variable is a variable that changes as a result of what you do to the object or the setup. So if I throw the object down, the independent variable may be that the object squishes more than if I just drop the object. Or maybe the object bounces higher into the air than it does if I just drop the object. The controller constant is a factor that stays the same throughout my fair test or experiment. So for example, the constant could be I drop the ball from the same height every time. The constant could be I drop the same ball on the same surface every time. Now, to conduct a fair test or scientific experiment, the rule of thumb is that you must conduct at least 3 trials for a fair test or experiment to be valid. If you only conduct 1 trial, it may be a fluke that you get the right answer, but maybe you don't. Or maybe you fail, but really it's because you made a mistake. You won't know. 2 trials, if you get different data, then you don't know which data to trust. 3 trials, at least then you have a tiebreaker so you can figure out, aha, this is the best option. If you can have more than 3 trials, obviously that's a better situation. You will be comparing a lot of your data to the data of your classmates, so ultimately you'll have a whole bunch of trial data to look at, to compare, to look for patterns in the information. So you should record your data and determine the average or mean of your quantitative data, if appropriate, for sharing with your peers. You'll be provided with spreadsheets to share out this information that will be posted for you. Look for patterns and trends in your data. Thank you, and have a great day.